Hi everybody, and especially those at the back. You should really be heading here and start paying attention. Yeah, because what you're going to hear is going to be extremely exciting. You learn a thing from the expert. Okay, Wisdom, thank you. I have to project it now as an expert. So it is an expert that can tell you that I even did Agile when you had to hide it from management. Isn't this exciting, right? So how many of you actually doing any software development? Anybody? Oh, okay. People, we are awake. So, do you know that things have to be actually secure these days? Do we know the value of security, right? Yeah. Okay, nobody knows the value of security. Fantastic. So, let's meet your insufficiently secured application that you have just built in Azure infrastructure. You follow all the best practices. You have gone through all the compliance. You ticked it off. So why this evil Alex is telling you it is still insecure? Any ideas? Huh? Somebody? No? Not a clue?
You have users?
Yeah? Well, almost there. Almost there. We have not just users, we have evil DevOps guys, because if they screw something up, if they kind of don't deploy correctly, if they don't copy to the right stuff, we get data breaches. Right? It's not for the first time that we get a situation where a data is accidentally or deliberately or through the stupidity exposed on the internet where people didn't think it is possible. Right? So, and if you Google how many data breaches we have, you will be shocked, because this is just the tip of the iceberg. And what a recurring topic is, there's a treasure trove, and it's not encrypted. So what you need to do in your insufficiently secured application, right? Yeah, we need to do encryption. But the question is, how? Okay, this is where it gets a bit interesting, and I'm going to present it to you in a funny way. So probably you heard a little bit about symmetric. Well, symmetric encryption, explained using Door the Explorer, it's just this lock on your diary, right? So you need to have two sets of keys for the sender and the receiver, and you kind of keep it relatively secure from the evil guys, right? Well, it's not the only one. There is also asymmetric encryption, which solves the problem that how do you distribute these keys, right? And it requires actually 4 keys, public and private, to exchange messages. I will not go into the details, otherwise, I will kind of lose you guys. But then, let's kind of continue. We have asymmetric encryption, and people still can't get it to us. But there is also the component of signing. What signing is all about. In this case, ESA can send stuff which isn't too secret, but Dory can trust that it really came from ESA, even if it might have been intercepted. All right? There is encryption. Finding encryption. Encryption, it means that hiding something from everybody except the intended recipient. And these days we have an interesting other topic that we're gonna touch on. Key wrapping. What is key wrapping? It's like if I will give you a secret and you give me something which is meaningless to the outside world, so that if anybody will get a hold of it, you still need to get to this originator of or the wrapper of your secret to figure out what is inside. And in this particular case, you need to authenticate with it. Again, guys, this is a complicated topic. Just bear with me. It will make sense a bit later. And last but not the least, the digital signatures. So if you work with Twitter APIs, or if you work with Facebook, you have come across these HMACs, public keys, private keys, API keys. They exist in all kinds of different form and shapes, and if you are tasked with the decision making, well, what do I need to apply to the new project? It's very easy to choose, right? Because they all work in a different way. So, if you are a solution architect and you have to secure your insufficiently secure application, where do you start from? You go to CIA. not this A, but confidentiality, integrity, and availability triad. And you see, well, how secure should it be in the first place? Because actually you need to consider a lot of kind of other things that also exist. And one of interesting considerations is threat analysis or threat modeling that you need to do. For example, can you expose the data? What is inside? What is the impact? What is the damage? What is the reproducibility of it? So it's a whole topic in itself, right there on the slide. But enough of the boring stuff. Let's start encrypting. So I'm going to introduce you to the topic of encrypting and key wrapping. So encryption and key wrapping is just like, is a key vault with an extra numeric lock on it. So you have seen it in offices all the time, and this is actually also what we do in cybersecurity. How does it look like? You have a good original document. You need to somehow come up with what is called a content encryption key, and you need to wrap it with something else. And then you get two pieces of information: wrapped content encryption key and ciphertext. Okay, so that means that whoever right now gets into it cannot decrypt it. How to decrypt? Oops. How to decrypt it? We need ciphertext, wrapped content encryption key. We somehow need to get back to our first content encryption key. Yeah, right now this terminology is confusing, and you need to wrap your hand around a bit. Then you need to get the content encryption key, and then you restore the original document. Right, it gets a bit complicated. If you work in financial organizations that touch on requirements that you want to guarantee that only the user is actually need to be guaranteed to have the possibility to encrypt it or decrypt it, there is also the architecture of a split channel sharding of content encryption key. What does it mean in simple terms? Is that your key is combined from what the application has and what the user has to type, so that nobody really knows what that key is. Okay, are you guys still with me? I don't think so, right? So it will get a bit funny. I know this is the boring part, and the reverse part works in the same in the same way that you have to ask your user and get to your original document. So that was the necessary introduction to to explain why we need to put a piece of the infrastructure which is called KeyVault. So KeyVault actually does all of that stuff for you under the hood, right? And it just exposes a few very simple APIs. You just say, well, I need to wrap a key, or I need to encrypt, and stuff like that. So how does it fit into your amazing application? Well, you just start putting these content encryption keys and key encryption keys in a key vault. Fantastic. Which results in a kind of architecture that, let's say you have here App Insights, that you want to monitor the access to it, and the data here, theoretically, is going to be encrypted. Brilliant, problema solved, right? Just one service, probably one of the basics that you have learned about Azure, but there is a problem. It's all great until you look at the price tag. Because Azure is brilliant for storing all these encryption keys in hardware security modules, but it has super expensive price to it. What I really want to talk about is that you can actually avoid spending thousands and thousands on Azure KeyVault services by just doing a little bit of programming. So how does it actually work? What KeyVault does, and this is what I was trying to explain to you, is all the same standard stuff, because in the end, what they do, they take your input, they pass it through some kind of implementation, and they essentially break it into kind of 3 data elements. Plain text, which you don't care, it's public, or doesn't seem to be confidential. So-called initialization vector, this is the required first step to start, and the part that needs to be protected, right? And then it somehow has to be stored in the database. It may sound as a super intimidating task, and I tell you, it is. Why? Because ciphers and encryption looks different in different programming languages. Welcome, polyglot. Haha. If you want to do that, don't. Because ciphers are named differently in different frameworks. They are created differently in different frameworks. So there's some kind of relationship, but it starts to get a bit murky. They are operated a bit differently. And on top of that, if you start just exploring Node.js, you start saying, well, there is this get out stack thing. It just didn't occur anywhere else. What on earth is it? And the same thing if you need to decrypt. There is this operation that Java and Go, for example, don't provide at all. Where the hell would you get it from, right? If you need to get the compatibility. So let's jump into another subject of tackling what is authenticated encryption with associated data is. It really is all about the elements here. So it starts with a random element, which is called initialization vector. You get your key, you get your associated data, and what it is for I'm going to explain it shortly. You have encryption key, which is really the only thing that needs to be protected. You get the algorithm, and which produces ciphertext and authentication tag. That's all. Previously, we only talked about ciphertext, but authentication encryption needs this element to tie the encryption to one interesting database object. Bear with me for a second. Now, to make encryption compatible between Java, Go, and TypeScript, all you need to know is that in Java and Go, authentication tag is simply written into the end of a string. This is where it is. So cut out last 12 bytes, boom, and you have your compatibility. Easy. Now, why do we need a tag, and why it is useful, and why do you need to know where to apply it? Let's consider the case that you have your fantastic app and you have your user, but through the set of unfortunate DevOps operations, you get your database exposed to the public internet. What happens? Let's say I'm the evildoer and I can, for whatever reason, register myself. But I can also have access right now to your database. And although I cannot decrypt it, what I can do, I can copy the data from the user I want to steal data from to my own. And I can then just read the data as if there is no protection. So the purpose for authentication encryption is to tie the data of the user A to the specific records in a database. Which means that if you will copy the data, in this particular case, well, they will not decrypt it. And that's actually the difference how the attacker would perceive it, right? Last but not the least, compatibility. Compatibility of programming languages, how to do 128-bit AES encryption. This QR code is for the public GitHub repo where the code is stored. Feel free to browse it. Of course, running this code and making use of this code requires quite advanced understanding of what the thing is. But then what I want to take you out of it is the size, so how much code actually needs to be written to encrypt and decrypt stuff. That's the crux of my presentation. Now, let's take a look. So, it's a bit hard to read. on a black screen. So what I want to do, I want to store the document and I want to get the document. And let's say I have a unit test which just runs the cycle of creating an object, put in there, and read in the back. So, and essentially this is what this piece of code does. So we got our Mongo client. It clears out and reads stuff and writes stuff and reads stuff. And as you see here, there is one element, which is a secret value that we will be trying to hide in the database storage. So if I will just write that stuff in the database, in the MongoDB, it will be clearly visible. Kind of Mongo itself doesn't give any protection. What I can do as a next increment, I can put some kind of wrapper that tries to hide those elements, and this is like just a piece of code that shows how it's decrypted and decrypted. So here I'm putting part of it in a data structure, and here I'm unwrapping it using the KeyVault. But then the net effect. So why do we do all of this? With these few lines of code, we get this exciting data structure that is stored in our database now. Good luck decrypting it. Why? Because this is symmetric encryption, and this is a wrapped key. So to do that, the only way actually to get it is to authenticate against our own key vault. So as long as we keep that key vault access secure, well, it's public information. Almost impossible to crack. And then going forward, let's say, what does it actually take to tie the data to a specific database record is to make this one line of code, to pass to the cipher what is called the authenticated data or associated data, and that's it. You get your data nicely tied to the database record. If we talk about Java, so if you want to make it compatible with the TypeScript, this is what you need to do to extract a tag. So it's literally that simple. So you need to know how long the tag is, and you just get a subset of the last output of the cipher. It makes it compatible with the TypeScript. And decryption as well. So, of course, do you see here tons of code? I don't. Do you understand what the code does? Probably not, but then that's not the point. The point is that, as Wissam said, we have to oversell ourselves, right? So come back to me if you need further help understanding what's happening here. Now, let's talk about the language which doesn't suck. TypeScript and JavaScript. How does it look here? Well, there is also in this repo a code example showing how to do that. And the beauty of it is that I love TypeScript for doing these operations because it's really type algebra, and you can very easily declare elements as protected, unprotected, and you can have, in fact, generic implementation. You can do it with Go and Java with libraries like Mapstruct, but it kind of sucks. TypeScript can do it for you out of the box. But then the the split end is quite easy, in fact. And then the only thing that you need to do is TypeScript or Node.js forces you to explicitly manage authentication tag of the output. But as you know right now, Java and Go just expect it at the end of a string. And looking at encryption and decryption, all you need to do is to call it this way. And this is where the differences between Go and Java literally end. You just need to know that this is what you need to do. And now let's take a look at how Go does it. Go does it in a very funny way because, in fact, unlike Java and unlike TypeScript, Go doesn't directly expose to you ciphers. So they offer through the API a selection of ciphers and paddings that you need to, if you're using Go in a project, you just need to know what they are, really. And in our example, to make the compatible implementation, you need to call this specific method. And that's it. And for the rest, you can just use the rest of the API, perhaps with this interesting Golang hack that if you get the ciphertext and a tag, you just need to use the spread operator when you merge the two slices. Yeah, that's all code. It's very simple, if you know what you're doing, of course. So, what I want to talk with you, the takeouts. If you want to do this for managing JSON objects, then the TypeScript is probably much better than Java and Go because it allows kind of generic manipulation of JSON objects. Go and Java, in this order, more suitable for encrypting large files. Why Go? Because it has a far smaller VM footprint. It's kind of really amazing. Signing that we talked about is great for detecting tampering. So it's if you have a requirement to report that you have suspicious activity, yeah, you need to do it. And last but not the least, whenever you do your project, you need to keep in mind that unauthenticated encryption, the encryption which doesn't manage these authentication tags, is only used to protect the data at rest. So it will not protect if if the attacker somehow got the access to your database. To protect against that, you need authenticated encryption, and you need to be aware about these exciting topics, right? And last but not least, before you start jumping into polyglot environment, you really need to research the compatibilities between libraries, between programming languages, and to do a POC to see which sequence of calls are there. What I have in a shared repo is a good starting point. Kind of feel free to clone and play around. So that's all, guys, that I wanted to share with you today.